All right, so your last question asked if you noticed any patterns between where the mountains were and where the plate boundaries happened. So again, I wanted you to notice that most of the mountains that we see throughout the world can be found where two plates meet. So again, if we look at the coast of North America, the western coast of North America is where we can find a lot of mountains. There are other mountains throughout North America, like there are some here, but the most pronounced ones that we see are on the western coast of North America. And if we look back at our plate boundaries, the western coast of North America is where the Pacific plate and the North American plate meet. And that's pretty true for all of the mountain ranges throughout the world. There are a lot of mountains down the western coast of South America as well, and that would be where the South American plate and the Nazca plate meet. So frequently mountain ranges happen where two plate boundaries meet. And again, that's because when the plates push together, they push the ground up. So sometimes when they push that ground up, they form volcanoes, and sometimes when they push that ground up, they form mountains. And mountains and volcanoes really are related to each other. So as two plates push together, they can create mountains or volcanoes. And again, sometimes when those plates rub against each other, that's how they would create earthquakes. And then those plates can also pull away from each other at times, and we didn't see an example of that in our maps. But sometimes the plates pull away from each other, and when they pull away from each other, that would create a trench or like a really big hole. So there's a pretty famous trench that's found underwater, and that's called the Mariana Trench. And it's very, very deep, and that's because two plates have pulled away from each other. So lots of different things can happen at plate boundaries.